So there are a lot of different well terms. So I want to go over a couple of the main ones when you see an image like this. So you can see here, you've got the house in the upper left-hand corner, and then right in the middle here is going to be our actual well. And so the well reaches down deep and is pulling water from our groundwater area. So the couple of terms I want to highlight here, we'll start with what is known as the zone of saturation. And so the zone of saturation is just the area in which the ground is saturated with water, right, or completely filled with water. You can think of it like that. It's that portion of the sponge that's filled with water. You've also got your static water level, and this represents the water level or where the water level reaches when there's no pumping taking place, right? When things are in a static, or in other words, a stationary state. So that's the level of groundwater when we are not pumping. Next, we've got what's known as the cone of depression. And you can see the shape that that kind of takes. Looks like a cone as it starts to taper down. And the cone of depression represents the area of our aquifer where water is pulled from, and the area above where you have the blue and the green colors becomes unsaturated, right? As you think of this well as a straw, and as you start to pump water out, the water has to come from somewhere and has to go somewhere. And so this area up top here is what then becomes unsaturated. We refer to this shape here as the cone of depression. We can also think of this level here as the pumping water level. So when we turn our pump and motor on and we start to pull water from the aquifer, the water level here is going to also lower, right? And so as we are pumping, the level at which that water lowers is known as the pumping water level. We also have what's known as the zone of aeration, and that represents the area underground where that is not saturated, right? So it's below ground, but it's not saturated with water. It's not considered the aquifer. That's typically where your plants and animals will live, in that area that's unsaturated, also referred to as the zone of aeration. The last point I want to highlight on this is the zone of influence, and that basically looks at more the horizontal reach of that well. So when we start to pump water from that well, how far away from that well is water being drawn from? Right? We may, dig a well at point A, but we may have a zone of influence that may be, 500 feet or 2 miles away. We've also got some other terms I want to go down here. So we have the term that's called drawdown. And so the drawdown is the elevation difference between our static water level and our pumping water level. So going back to our previous diagram here, we can see we have our static water level, and then we're going to end up with some pumping water level. And so the difference between these two, when we have that pump and motor on, the amount of water being pulled, we refer to that as the drawdown. Now we have what's also called the well casing and the sanitary seal. So the well casing is actually what surrounds the well portion that's underground, right? And so that well casing prevents the well from collapsing on itself, so it gives it some stability. It also prevents contamination from other groundwater sources. So maybe we've got, a big farm over here, and we have pollutants that are seeping into the ground here. And so as that pollution kind of makes its way toward our well here, this well casing would prevent that, so that we're actually pulling the water that's deep down here that would be potentially uncontaminated. You also have what's called the sanitary seal, and the sanitary seal actually sits at the very top of that well, and that prevents any surface runoff here from contaminating our well or making its way back into the well here. And the last term we have here is what's called the safe yield. And so that's the amount of groundwater that can be withdrawn without causing this long-term damage or long-term decline of water levels, right? In other words, it's the recharge rate, or the amount of water making it back into our groundwater, is equal to the amount we are pulling out, right? So that we are using this water at a sustainable level. And so there's an equation for that that I want to go down. When we look at kind of how much can we actually pull per unit of drawdown, right? So we refer to this as the specific capacity. Now, the specific capacity is given in